Hello my dear students, today I am going to discuss the topic basic concepts of probability. So let us discuss what is meant by probability and what are the examples of probability and who are the developer of this probability. The concept of probability was organized in 17th century. The technique of probability was developed by James Bernoulli, Thomas Bayes and Laplace, etc. So what is meant by probability? The probability is a numerical measure and it is a chance of occurrence. For example, suppose a fair coin is tossed once, the result may get head or tail. Here the chances of getting head and tail are equal. So probability is a numerical measure and it is a chance of occurrence. Then there are two types of the experiment. The first one is the random experiment and another one is the deterministic experiment. So what is meant by random experiment? Random experiment is an experiment which is repeated under the same condition and it does not have a unique outcome. For example, suppose a fair coin is tossed once, we cannot predict the outcome. Either it will get head or it will get tail. So here we cannot predict the outcome. This is the example for random experiment. And one more example is throwing a die and drawing a cards from the playing card. And deterministic experiment in the sense, deterministic experiment is an experiment which is repeated under the same condition, and here we can predict the outcome of the experiment. For example, suppose an object is thrown into a space, it always returns back to the earth. So here we can predict the outcome. If the experiment is repeated many times, the result is same. So this is the example for deterministic experiment. Now we will move for some other basic concepts related to the probability. So sample space. What is meant by sample space? The set of all possible outcomes of a random experiment is called as the sample space. For example, throwing a die. So throwing a die, the possible outcomes of a throwing a die is 1 to 6. That is 1, 2, 3, 4, 5, 6. So the sample space is denoted by capital S. Then there are two types of the sample space: finite sample space and the infinite sample space. So finite sample space in the sense, the sample space which has a finite number of outcome. For example, tossing a coin. Tossing a coin means the outcome is head or tail. And throwing a die. Throwing a die, the sample space is, it has the finite sample space 1 to 6. And infinite sample space in the sense, the sample space has the infinite number of outcomes. That means, for example, number of stars in the sky. Then event. Event in the sense, event is a subset of the sample space, and we will denote the event as A, B, C, capital A, B, C, or up to Z. So the example for event is, consider the sample space. The set of sample space is throwing a die. So throwing a die is sample space is 1 to 6. Then the event is multiple of 3. Multiple of 3 is 3 and 6. So this is the one of the event related to the sample space. Then types of the events is simple event, compound event and null event. So simple event in the sense, an event which contains only one outcome. That means consider the example of throwing a die. So it has the sample space is 1, 2, 3, 4, 5, 6. So simple event in the sense, the results show number 6. The results show number 6 in the sense, 6 is only one outcome. So this is the example for simple event. And compound event in the sense, an event which contains more than one outcome. For example, multiple of 3 or odd numbers. Odd number in the sample space, the odd numbers are 1, 3, 5. So here there are 3 outcomes. Therefore, it is the example for compound event. Then null event in the sense, an event does not contain any outcomes. For example, the results show the number is 7. 7 is not included in the sample space. So this is the example for null event. Then sub-event. An event A is said to be sub-event of the event B if the occurrence of A implies the occurrence of the B. For example, consider a random experiment of drawing a playing card from the packet of cards. Event A is drawing a spade card and event B is drawing a black color card. Here we know that spade cards are the black color cards. So whenever A implies the occurrence of B also. The notation of sub-event is A sub-event B. Then union and intersection of the events. Union of the events in the sense, if A and B are the two events, then the occurrence of at least one of them. Union means event of occurrence of at least one of them, and it is denoted by A plus B. And example is, suppose consider again here in every probability problem, most of the times we are considering the throwing a die example. So S is 1 to 6, A is multiple of 2, 4, 6, and B is multiple of 3 and 6. So the union is 2, 4, 2, 3, 4 and 6. Then intersection of the events in the sense, the simultaneous occurrence of the both events. For example, in event A 2, 4, 6 and in event 3 and 6, the simultaneous occurrence is only 6. So this is the example for union and intersection of the event. Now complement of an event. Let A be an event, then complement of the event is the non-occurrence of the event A. For example, the sample space is 1 to 6, then event A is 2, 4, 6, then A complement is non-occurrence of the event A, but it occurs in sample space, that is 1, 3, 5. Then next definition, mutually exclusive events. Two events A and B are said to be mutually exclusive events if they cannot occur together. For example, while tossing a fair coin, it will get head or tail, but it does not comes together, head and tail. So this is the example for mutually exclusive events. Then exhaustive events in the sense, exhaustive events are said to be the union if their union is equals to the sample space. For example, sample space is throwing a die and event A is 2, 4, 6 and event B is 1, 3, 5, then the union is 1, 2, 3, 4, 5, 6. Then different methods of studying the concept of probability is classical definition, axiomatic approach and empirical definition. Then classical definition of probability is, let a random experiment have an mutually exclusive, equally likely and exhaustive outcome. Then out of this, M are favorable outcome to the event A. Then we can write it as probability of A is equal to favorable number of outcome to the total number of outcome. This definition is applicable only when the outcomes are equally likely, mutually exclusive and exhaustive outcomes. Then there are three important results are there. So these three important results are applying while we are solving, when we are solving the problems. So the first results is probability of A plus probability of B is equal to 1. Probability of A and the complement of probability is always equal to the 1. And one thing here we have to remember, the probability does not exceed more than 1 and it does not contain negative value. So the probability is always lies between 0 to 1. 0 to 1. So the next result is probability of A dash is equal to 1 minus probability of A. So these are three important results and this is applicable in every problems. Here we have discussed some basic concepts related to the probability. Now we will move for addition theorem of probability and its proof. It will discuss in the next class. Thank you.